Hi, Michael. Welcome to Airhacks FM.
Thank you very much for having me. I greet you.
And what was your first computer?
My first computer, let's say, basically it was a desk calculator, the Texas Instruments 58C, which would allow you to program small functions, for instance. But my first real computer was the Tandy Radio Shack 80, so the TRS 80.
Okay, this is unusual in Germany, right?
Yes, I bought it in one place in Munich. This was the only computer shop in the 80s. So I got it from there, and I was very happy because it had 16 kilobytes of RAM.
Was it the shop was near the central station in Munich?
Yeah, absolutely. Schillerstraße. So.
Yeah, this is what I bought my machines as well, but later, much later. So most of my first servers were assembled from parts from the Schillerstraße shops.
Yeah, that's true for me as well. So this was basically a place to go for finding computer equipment and parts.
But the shop was really strange because you had exactly know what you would like to have. Mm-hmm. So I remember once I forgot which kind of RAM bricks I need. Mm-hmm. And they say, what do you like to have? And I, okay, then go out. And I had to go out, and stand in the queue again and then think exactly because there was so many customers in the queue. Mm-hmm. Is the shop still around, No.
No, I don't think most of the shops are not around anymore. So they have given up. So ESCOM, which was a very large company there. And I think even the electronic shops have disappeared.
Okay.
Most of them, at least.
Okay. That's unfortunate. But I think maybe this was 2005-06, the last time I bought something there. So it was not that, and they had excellent parts, so motherboards and they had everything on site. Mm-hmm.
Yes, but you're right. You had to absolutely know what parts you need because I think the people in the shop did not know exactly the electronics and what you really needed. They just handled it somehow. And therefore it was really important to know exactly, I need this controller for the hard disk and I need this power unit and so on. Yeah. So I remember that. Yeah, it's 40 years ago, for me at least.
No. What you did with your first computer? So you started immediately programming or you played games?
So the first thing was I started it and saw the basic screen. So I had to learn basic. And I built a Star Trek game.
Wow, not bad.
And I forgot, I left my home and I forgot that the whole 16 kilobytes were filled with the code. And my mother thought, okay, it's still running. Maybe she can shut it down. And that time I had no cassette recorder, anything like persistent storage. So everything was gone.
So you were not happy?
No, I had to reprogram everything from scratch again.
So this is, but the next version was better or worse?
So the next computer I had basically
No, I mean you have to reprogram everything from scratch. So was the reprogrammed version the new version?
I had some ideas, and I also had some ideas what would be wrong or not as optimized as possible. And so I used the old architecture, refactored it a bit, and then re-implemented the game.
But you wrote something down, or you had everything in head, yeah?
I had everything in head, so... No, writing down. I started writing down everything in the university when I studied, and that was something like a pleasant experience. So I had to build a functional language for a compiler generator.
You know what it is? What you invented? Agent memory, right?
Yes. Yeah, absolutely.
The first conversation, 16 kilobyte, the context was reset. And then so I need an agent memory. Exactly.
Yeah, that's exactly. And so that's why I then bought later on a cassette recorder to store and load everything I needed.
And you had to modify that. So what was possible to buy a normal one? Or do I remember you can modify something so that it was suitable for computers? You can refactor the existing, or you bought a special one.
No, I was fortunate that there was a TRS-80 special cassette recorder, which I could then use for this purpose.
Because I had ZX Spectrum and it had already the recorder. But I think before I thought about refactor my music recorder to be suitable for the computer. But I actually forgot what was needed to do. But it was not that hard, but it was possible.
Yeah, but in that time you really had to be an experienced guy in order to know what you buy. And the first thing I bought was basically a disassembly and debugging tool in order to see how what is really stored in RAM. So if you, or how could I change the basic programs to add assembly, for instance, or to integrate assembly, which was really a tough thing because you had no really support for that and no one had written about this possibility. Also that was, I think it was the C80 chip as far as I remember. And so I had to read the whole C80 specification, see how to program in C80 code, and then using the basically debugging monitor to put in the code instructions.
Why is you so interested in code? I think the others played more games, right? But your first thing was to implement a game. So why? I mean, what triggered your interests?
So basically the reason why I got the C80 was I had at school math and physics, and our teacher always tried to show on some very expensive, I think HP computer, how to basically calculate formulas and how to print a nice graph. So I was really impressed, and the first thing I always do is I'd like to implement something to get really a feeling for the hardware.
Oh yeah, interesting.
So
on a skit, because the TRS, the trash computer, you started also programming. So I mean, usually what kids are doing, they are just playing games first, and then they try to get infinite life or try to hack something. So, but you start coding. Wow.
Yeah, that time there were not too many games around. So I don't know exactly if there was one game. I don't know. And then most things were in magazines, printed basic code, which you had to enter to your computer in order to play that game that was then listed in a magazine. So
okay. So this was fortunate because
I had to implement the game myself in order to play it.
Okay, what was the game about?
Basically, it was a kind of adventure game where Star Trek Enterprise is flying around in the universe, and then there might be some planets, there might be some conflicts, and so it was basically
a text-based
adventure game with graphics in order to show the location or something like that, because otherwise you wouldn't have exceeded or succeeded in really using this 16 kilobytes of RAM, because it wasn't sufficient to have really sophisticated graphics, or you could only use ASCII graphics, and
you have to publish this on GitHub. It would be right now. Yeah,
right now. I don't have the computer anymore.
Yeah, but you have from memory. You have to. You have to do it again.
Yeah, nowadays you might use wipe coding. So here's the game, please develop it. But that is only not that much fun from my viewpoint. In order to learn the system, you have to really get your hands dirty. And that's what most people forget. If I just use, for instance, an LLM to generate the code, then this might work or not. And I have no idea, no clue about why this works and why this is structured as it is.
You're absolutely right. Yeah. But we have to talk about you. Otherwise, we will immediately talk about LLMs, which is even more is also interesting. So, so you studied, you got the C80, and you started to what? You wanted to learn the hardware better, and this is why you started coding, or you started coding.
Yeah, absolutely. Yeah. And I was sure that I would basically study computer science in the university, and originally I wanted to study physics, astrophysics, but then everyone told me, forget it, because there are no vacations or no vacant jobs in Munich. And when I completed my study, there were a lot of possible positions out there, because there was Max Planck Institute for Extraterrestrial Search, ESO, ESA, all of these organizations that were not available when I started my university studies.
But you enjoyed your computer science study, or?
Yeah, I really enjoyed it. But the only critique I have is you could basically get a diploma without having any computer programming capabilities.
Yeah.
So it was really on a mathematical abstraction, and you could easily program nothing and nonetheless get the degree. And I thought I would like to know, and I am a person, I always want to know why this works. And how this works. So for me, it was important to learn C at the university, and Pascal, Turbo Pascal, which I got 500 meters away from where I live. There was the Borland garage. So I went there, and they got in the garage, took out one of the packages, and then I got my Turbo Pascal.
This is where Borland started?
It was that time. It was not Borland. There was a guy, I don't remember his name, Heimsöth, yeah, and he was basically responsible for the distribution of Turbo Pascal in Germany.
Okay.
And as I said, they were 500 meters away. Later on, Borland had also an office 700 meters away from me. So I had always a short distance walk to Borland or Heimsöth that time.
Okay, that's cool. So you started. You used C and Turbo Pascal in university, and what happened? Or maybe what was the most interesting C or Turbo Pascal project you did during your university time?
So as I said or mentioned before, I was basically building a functional interpreter for a functional language, for attribute calculation and computation. And this was part of a compiler generator project with visual UI. Wow. So you could not only put in a grammar, but you could also see the grammar as a tree, change it, put some attributes there, and use it. And that's why basically was first of all my I don't know how it's called today, Vordiplom. So we had basically after 2 years you had to do the Vordiplom, and there I wrote the functional interpreter. And when I had my diploma thesis, this was basically an optimization of the whole compiler constructor.
It's a crazy complex. I would say this is almost like a product, sounds, right?
Yeah, this was basically in cooperation with Siemens, my later employer.
Okay.
And so that was the reason why I went to Siemens. But unfortunately, only shortly after my starting my career at Siemens, they basically they stopped the project and canceled it. So
What was a research project or was it used somewhere?
It was basically a research project, and Siemens, as far as I know, wanted to use it because they had a really big compiler division where they built all of these compilers for huge, let's say, mainframes, for workstations, and so on. And that was basically the idea, to use that there.
I was also briefly at Siemens internship, and this was actually a cool story. I remember the systems conference in Munich, right? And I had a Java workshop, this one IDE, and I had some questions, and there was some microsystems booth on the systems. And I went there and asked questions, and there was someone who listened to me, and I said, okay, you know Java? And I said, yeah. And he was from Authorized Java Center Siemens. And he asked me, and then I worked for Siemens as a student, maybe for 1 year in AGC. I remember in a tower in Munich. It was also nice. It was like Siemens back then was cutting edge regarding Java, internet, stuff like that. What I even remember, we were in department, and they had their own Siemens application server. They implemented Siemens application server from scratch. So I chatted with them.
Yeah. And the problem is that this was not limited to one business unit, but I had the same problem when we built an ATM, basically a router, that there were 3 different business units building an ATM router. So, and they did it, of course, they did it themselves because this was the public communication business unit. But I was wondering, I always told them, if you put together your energy and time and people, you could provide much more than only everyone building its own kind of application.
But it could be also smart, if the management is up to that. It could be like a competition between departments, and the best one could win and just pick that and go with this. So this would be also interesting.
Yeah, the problem is that at that time, people thought that IP might not sufficient, and why not use ATM? Which is a package system where you have exact time intervals where packets arrive. And depending on the priority, you get more or less packets. And but they really ignored Cisco, which was basically using IP as the fundamental platform or infrastructure. And so the ATM basically was cancelled later on. So all 3 were cancelled. Also the winning one, which was basically a competition, as you said, between 3 business units. The winning one was then basically announced and then cancelled because of the world had changed, and it was clear that IP was the solution to go with.
But you stayed in Siemens, right? After your research project was cancelled. What was the goal of the project at Siemens? Was it just general research, or they wanted to?
The first project was basically part of the standardization of C++. Wow. And we proposed to introduce meta information, so some kind of reflection into C++. And we built our own C++ version in order to really play around with type information. And this was basically the platform to use for showing that what we proposed as a standardization was really working and how it was working. So that was the first thing I did. It was basically build a C++ parser that adds information to the program in the source code level and then gets fed into the C++ compiler, and then you basically got by instrumentation you got then all of these topics. One business unit wanted to use that for persisting C++ programs.
Almost JPA, right? Sounds like.
Yeah. And the other was basically was interested in runtime reflection. So how can I find out information at runtime, what happens and why? So there were different reasons for that. And later on, it was standardized. So it's now part of the NC C++ standard or NC ISO C++ standard.
Exactly your work is a part. So now you can find some ideas in the standard.
It's not only my work, it's the work of different people. Of course, they implemented it their own way. They looked at our code. We did not build it into the compiler itself, but instrumented existing C++ code in order to add these functionalities. And of course, the compiler constructors from like GCC or whatever, Seafront from AT&T, they implemented it themselves into the compiler. So it was part of the language specifications. And but primarily what you see today, at least parts of it, are what we basically created that time.
That's interesting. Huge impact, I would say, right?
Yeah, that was fine. And so, from beginning, I started thinking about architecture. So I had a clean architecture, I would say, for building this instrumentation. And I had also an experience in the university. So for my diploma thesis, I had a huge slide of paper and wrote the architecture on a paper and then implemented. And there were 2 or 3 syntax errors and it worked. Was not too much code, of course. It was about 10,000 lines, I think. But it worked immediately with only 3 syntax errors. And there were no semantic errors or no architecture errors. And so I thought, okay, it's better to have an architecture to build software. And later on, and then we went to the area of patterns. So from beginning on, I was really heavily invested in software architecture. And
when it happens with the patterns, was it during the C++ standardization effort? Or?
Yeah. So we started basically to think about patterns, and then we decided to write a book, the pattern-oriented software architecture book. And we worked in parallel with the Gang of Four, so with Erich Gamma and the other guys, in order to make sure that the books don't overlap. So that there's no pattern in one book that is already in the other book. And so they came out in, I think, if I remember correctly, 1995. And we came out with our book in 1996 on the Uppsala conference. So that was how I came. Basically, one of the first things I also did at Siemens was a business project with the private communication people. And I analyzed basically middleware for that purpose. So which middleware could you use as a base? And so
By the way, I have your book. I immediately bought it because I bought the first one was Gang of Four. The first edition was C++. And I was a huge C++ fan because I really appreciated also the book from Björn Strustrup. There was like a thick book from Edison Wesley. So I really liked it. I don't know why. And then Gang of Four first edition was in C++, but then in Java. There was also one, what I remember. And then your book was a little bit more evolved because the Gang of Four patterns were more basic and more was, I would say, a little bit more enterprisey. And I actually searched for the book. I still have it next to my next time I will show you. And they are I'm just on Amazon. They are still available. And the book made a huge impact actually on the software landscape back then.
Impact. I was surprised. Yes, and at that time, Java was around, and that's the reason why in POSA, in our book, there are also Java examples. So all patterns with Java examples were basically created by myself.
So when you learned Java and why?
So sometime a colleague came to me, Hans Runert was his name. He was also one of the authors of the Prusa book. And he told me there's a cool language around Java. And he thinks this will basically be a danger for C++. And in the beginning, I thought, oh, no chance. C++ is very efficient. Why would anyone use an interpreted language? But then I looked at the language in deeply, and I found out that, oh, that's a nice language. Write once, run anywhere. You can build applets and whatever you could build that time. And it was basically one book, Essential Java, or Java in a nutshell, sorry.
John Flanagan.
Which you could read in one weekend, which might be a little bit different to today, where you could write any Java book that really covers all of Java language and JDK specifications.
Yeah, there were two books from John. This was Java in a Nutshell and Java in a Nutshell workshop, I think, and the workshop had examples, but even but really sophisticated examples. I remember proxy server, network proxy server was there, so this was really deep dive for that time, because other books, they were somehow fluffy with Java. Sometimes the first 50 pages was some concept, and there was Javadoc printed out. You remember there were lots of books with printed out APIs, for instance, back then, which were really thick.
And that was really astonishing. So when I was at the first OOP conference, or one of the first, I met a guy from Sun, who was basically the Java evangelist for Sun. And when I spoke with him, I really recognized that he had basically no idea how to program Java applications. So I was wondering if this is the evangelist for Java, then I'm not sure
whether it will work.
Yeah.
You know who it was? Who was it?
No idea. No, this was a guy who was always talking about Java at the OOP conference.
From US, right?
Marketing.
From US?
I think he was from Germany. The US guys I met, they were really smart and really knew about Java, but the German guys, I think they were more for marketing purposes and were basically forced to learn Java or know something about Java in order to sell their products.
What it could be, because at the same time I worked as a freelancer from time to time for Sun, Germany. And by the way, I know Siemens people from the AGC who also worked Sun Microsystems as a trainer, as a freelancer from time to time. And some of them, I think, spoke at the OOP, and they were marketing people. So I remember there was one was a really nice guy, and he loved Java, but he never programmed anything. But he sold the Sun workshops and courses. So I think it could be that the Sun. What is called Sun Java Centers, SGC?
I think it's Java Competence Center. Because,
Java Competence but AGC was at Siemens. This was, but one was at Sun, and Sun. I was in a Sun. I worked for Sun, and they only made workshops and a little bit consulting, and they had a special name. And I think these guys also were at OP from time to time.
So basically, I got a job offer from Sun Microsystems that time in order to really take care of all the Java competence centers in Germany.
Should be cool.
And the job was basically, we want to use Java to sell more workstations.
This is not true, because I was a Sun trainer there, and I wanted to buy one, and they had no process to sell me. It's like, I give you money right now. Give me the workstation, please. No, it's impossible. We are a subsidiary of Sun in Germany. We have to ask the other department. So they had no idea how to sell me the machine. This was actually funny.
So they didn't want your money. That's interesting.
This is even stranger. I told this on the podcast several times. I wanted to buy the Sun Java Workshop and Sun Java Studio IDEs. They cost like 200 marks, so like 100 euro right now, or 200 euros, it depends. And in order to do so, I filled out a form, I remember. And what I got is, first, a call from a Sun management, which and they made interview with me, which was, why? And then so, okay, then nothing happened. Then I got a really nice book with printed book, colored, so like coffee table book, and this was catalog of all the Sun stations, Sun workstations. And then I could buy the software. And what I found out later is I became an enterprise client with credits.
Okay.
So I could actually buy the largest, machine from Sun without having any money on credit. And but this was this was really crazy. So business-wise, Sun was not the best, but I really liked the company. They were like nice, hippie.
Yeah, they were not far away, located in the Munich East part.
Heimstetten.
Yeah, right. And I knew also some people from there. And I'm really sad that they vanished. So they were bought by Oracle, and then no more Sun Microsystem stuff anywhere, I think. I don't know whether Oracle is still selling Spark stations, but...
no more. And Oracle is, Oracle are more reasonable, but a little bit boring. So Oracle is perfect for Java. I mean, they do great job, but in Sun was more exciting. You never knew what happened. So they had lots of crazy ideas, and this is what I appreciated. And Oracle's a more predictable company which executes, to earn money. And Sun was not just money; it's also the spirit.
Yeah, but
this was
what I like is basically we have a guy from Oracle, Wolfgang Weigand, who is basically in our advisory board for the Java Spectrum magazine. And he's a very smart guy. He gave me some pointers to other people, for instance, to the people building the JVM. And so I got interesting people to talk to, and is really helpful. And he is one of the best experts in Java. So nowadays, these people are really clever and smart.
Yeah, but Wolfgang Weigand comes from a BA. He was a Java guru all the time, So this is...
Yeah. But he's really clever, and he knows theory and practice. And he's a very good guy. Very nice guy, and also very knowledgeable guy.
And yeah, nice. I like him. We always have a chat. We are on conferences. And he also extended the OOP conference with Java. I think he was in charge of some Java developer day at the OOP years ago. He was always involved in Java in Germany.
Yeah, that's true. He's one of the drivers in Germany. Absolutely.
And which version you started with Java? JDK 1.0, the first one, or later?
I think I started with the first one, because when the first one came around, my colleague got the information from somewhere and told me, you should look at that. This is where I said, no chance. It will never surpass C++ in applications built. But I erred. So it was my wrong, basically, anticipation. And then later on, it was really everywhere. So
yeah. And you stick with Java at Siemens then?
I'm still sticking with. So at Siemens it's more difficult, because we have people programming with .NET. We have people programming with Java. You'll also find some Go or Rust implementations there. So I also met a Fortran application some years ago, which they then converted into a C# version. And so we have a lot of different languages, but I think Java is really one of the most important. But we are using C# as well. So, for instance, the automation guys are really in C# and these technologies.
But since your first experiments with Java, you switched to Java more at Siemens, or was it depending on the project? So just about you.
So at the beginning, it was really tough because no one wanted to be the first to implement a larger application with Java. So it took some years, until the first proof of concepts were built with Java, and then full applications were built with Java. And I think it changed. First of all, the first trend was mobile smartphones, or handies, as we call them in Germany, and to bring in the screens some Java games. And so we participated in the micro edition Java.
Java 2ME.
And so this was the first wave, I would say. And the second wave was when enterprise Java came around. And then really Java was used almost everywhere. So EJBs and whatever. That time there was no sprint around, no Spring around. And so at the beginning, when Java Enterprise came into existence, a lot of people at Siemens, and I know also other companies, used Java for their, at least for their enterprise stuff.
Yeah, a lot, exactly. This was also what I did at Siemens. So we built with enterprise Java. I forgot the server actually. We a system for job scheduling, something like this.
And I think that time it was IBM WebSphere or BEA.
And the Siemens one, I will have to look the name. So there was so actually it was my idea. It's like, we at Siemens, you are for sure on Siemens application server. Then you should use this first. And they told me, oh, okay. And then we found a department in Munich, and this department implemented the server, but it was not that capable. It was it could only support stateless EJBs, nothing else, and we needed more, so we used something else. But it was actually a nice experience at Siemens. Nice memories.
I guess you are using non-persistent EJBs and plus Hibernate or something like that, because that's what most people did at that time. And the thing is that at Siemens, we are mostly building embedded systems. So even an ICE train is an embedded system, or a tomograph for healthcare is an embedded system, and so on. So we are mostly dealing with implementing at least embedded systems where C++, maybe Rust are the basically main containers. And for our enterprise systems, and you know that SaaS and so on, more and more people want to have additional services and monitoring, observation of the products, and deploying the products. All of the operation stuff are using also Java.
Okay, cool. And so you're still working for Siemens right now?
Yeah, not long. So now it's the 35th year.
Wow.
But end of March, my active partial time activities for Siemens will end. And I will have the passive time. So unofficially, I'm leaving Siemens at end of January 2028, but officially, I'm not working anymore for Siemens from April.
What, is it your choice?
Yes, it was my choice because I had some health problems, and that's the reason why I would like to stop. And but I have some plans, for instance, studying physics in the university.
From scratch? Starting to study physics from scratch?
I know physics a little bit, not that extended knowledge that you really need to have to research physics, but at least basic knowledge to understand most concepts in astrophysics.
That's a cool idea. That was your dream from back then.
Yeah. And now I can do that, what I always liked. So I don't want to stop learning. That's the issue.
This is also my plan. As long as you learn, you have fun, challenge yourself. And this is actually the main idea. And if this is working, everything is fine.
Yeah. So you can learn, and then you can teach other people about these more complex topics in seminars or so in talks. So this is basically why I also won't lose my connections to artificial intelligence and software architecture, probably.
Yeah, we cannot ignore LLMs and agents. They won't disappear. This is what I know, right?
Absolutely.
It's too much money involved, so it will stay. And even if the company get bankrupt, the technology is out there as open source, so it will still remain. So it will be picked up by communities. So regardless what happens, LLMs will remain here.
Yeah, and that's the reason why the shares are basically are very volatile in the last months, because the money which is in this whole LLM stuff is very, very much high money. So it's also a danger. So if the expectations are not fulfilled, then so as you know from the Gardner curve, then there will be disillusionment. So I think disillusionment has not started a little bit, but we are more or less coming to the disillusionment part.
So what I don't understand is a couple, this is more high level now about LLMs and money. I think we reach plateau. They are crazy good, but it's not like Opus 4.6 is orders of magnitude better than 4.5. It is a little bit better, and 4.5 was already great. So I mean, and if they pour more money into LLMs, the typical user won't recognize the difference. So they will never recognize the difference between Opus 4.6 and 5 or ChatGPT 5.3 and 6. So because already, so I mean, this is already good enough, I would say. The next thing,
even for code generation. So I made some experiments with code generation, and I used Anthropic Claude 4.5 Sonnet, and it was really having some smaller errors. And the problem was that Claude was generating code to eliminate error 1, but still include error 2. And the other way around. So it took me half a day to really help Claude in order to really make this code correct. So I think even these are things which are easy to see as a developer. But I'm not sure whether if your life depends on an LLM. For instance, if someone would build an LLM-based code for an airplane, I won't ever enter this airplane.
Yeah, you are right. But this should be topic for our next session, because it is a lot to talk about LLMs and AI. So but what I wanted maybe to conclude with the LLMs and money. So first, there's like plateau reached with the current technologies with transformers. And I think if they pour more money and the general public won't see the difference, so we get a disillusionment because they're promising a lot, but I don't know whether it is possible with the current technology to be orders of magnitude better than what we have today, because it's already very good. And the next thing is everyone thinks that the next generation of LLMs will require far more computing resources, and that's why they build huge data centers, which are very, very expensive. But this is, from what I see, more like brute force approach. And what I think might happen is that someone finds out, okay, we don't need actually an AGI LLM. Maybe we have more specialized LLMs, and then do not require that many computing resources, and then the whole investment is questionable. Maybe it could be used for something different, but we don't need so many servers. So there were the two problems what I see from the economical perspective.
What I see is also, I'm skeptical about AGI. So I told this everyone in my blog for, I think, at least 2 years. Whenever I saw some YouTube video about, AGI and ASI are around the corner, I told them that's not possible, because basically with the transformer architecture, you can never reach the same as a human or smart creature. Because it's not in the architecture, it's not possible. There cannot be any consciousness or context memory, almost infinite. So that's impossible. And I'm not that optimistic about what LLMs can do in the future. I think it will take a long time to really make them AGI capable.
Yeah, and what they also need the knowledge of the world to as we see the world. Otherwise, they will never understand us directly. You have to provide additional context, not like, because human to machine, lots of information gets lost. But if the machine would see the world as we see it could be easier to machines, to derive the context.
Yeah. So that's what we basically make in physical AI. So there's a cooperation between Nvidia and Siemens, for instance. And this is learn and teach the LLM or the robot or whatever you are using to really understand the world around you. Not the full world, of course, but for instance, the production floor of a factory or something like that. So that's the next step, of course, but it's not AGI. It's still, I have, like you said, a specialized LLM for a specific purpose, and I'm using that. Maybe I have fine-tuned it for the specific purpose or trained it myself, and then it will do things in a limited domain, and this will be done in an excellent way. But it won't be able to do everything at once and know everything at once. And the context memory limitations, as you might have seen, you can bring it down to n times the square root of n instead of having n squared. But nonetheless, if you have, let's say, 100,000 tokens as a context memory, then it will take you multiple gigabytes to really store that in the KV caches of the LLMs. And my experience is that if you overdo it with context memory, then it won't work. So all of these 1 million tokens context memory,
you will lose the precision and heavily. Yeah. So lost in the middle, there are lots of, exactly.
So I think it's more theoretical. Okay, maybe Gemini 3 Pro has 1 million tokens.
But it's not usable. It's not usable.
But it's not usable. You can use, as you see in most tools, let's say several kilobytes of context memory.
Yeah.
But not megabytes or even more.
Just back to you and then cliffhanger for next time, because I would like to tell you what I found out with LLMs, which is maybe surprising to you or not, depends. What were your, maybe, can you briefly introduce the patterns from your book, by names and what they are doing, just know as cliffhanger?
Yeah, let's start with the architecture pattern. So with the broker pattern is basically how to build middleware, so how to broker between different clients. We have the micro service architecture, or micro, that's basically like...
Was it in your book already? No.
Yeah, microkernel, sorry.
Microkernel, yeah.
We had microkernel in the book. We had layers in the book. So I think everyone knows about layers. We have also, let me think, pipes and filters, which is also an architecture. So pipelines, if you like, and blackboards. So as a means to let different agents communicate with each other. Which was basically used for language recognition, but was then used for letting anonymous, autonomous devices communicate with each other, like in a mobile phone cell.
And yeah, there are foundational patterns. So this pipe and filter, I forgot that is from you, but it is there's a different name, but I use it. It's not from hexagonal architecture, right? This is also this is actually from exactly.
And we have, of course, publisher, subscriber, and basically a forwarder, receiver, for instance, client, dispatcher, server. So there are some patterns more on the let's say communication part or domain, and we also have more general patterns like publisher, subscriber, whole part, and so on. So there are, I think we had 13 patterns, but I'm not sure.
Okay, because the pipe and filters with patterns a little bit dangerous, because there are some developers who love patterns, and I was in many projects, and they ask me, what's your opinion about hexagonal architecture? And hexagonal architecture, pipe and filters make sense if you don't have your own platform. But what I always used was my application servers. I'm my Quarkus right now. Everything is Quarkus. And then in order, to expose REST endpoint is one annotation path. And right now, what I have in most of my microservices, they expose the business logic as REST and MCP, for instance, Model Context Protocol. So in Quarkus case, there are two annotations. So it means I have two classes in one layer, and one exposes the functionality via REST, JAX-RS with at path, and the other one with at MCP, and I'm basically done. And so it means for me, the pipe and filters is already ingrained in the platform. So I have nothing to do, it's already there. But there are many projects out there, and I perform code reviews, and consulting, and they thought they have to build on top of that. So one extreme case, they said HTTP could change at any time. This is not a joke. This is a real project, and they started to decouple from the JAX-RS. So they had their own adapter, which created HTTP events, which were sent then to JAX-RS, and they could replace basically HTTP and say, you are all crazy, why are you doing this? So I would say you should use patterns if you have the problem. And what you should always do, this is my opinion, is to establish something like convention over configuration. I would say in our project, in our world, HTTP is the default. So I don't have to abstract from HTTP. Let's keep it simple. So what's your opinion on that? Because you invented the patterns. So what is it reasonable?
No, first thing is we didn't invent the patterns, we found them.
Yeah, sure.
For instance, I was basically involved in Microsoft's COM, DCOM, Corba, RMI, and so on. So I figured out that some parts of these middleware platforms look identically. So then I really extracted patterns which all of these middleware systems used. So I did not invent them, I found them, and I basically documented them in a more general way. And the problem which you are coming up with is, yesterday I've published an article on my LinkedIn account on how to use patterns. And people often use patterns in the wrong way. And they don't see that actual patterns are really implemented in the platform itself, in the infrastructure. So they don't have to care about that anymore. And in your case, basically, it's really a complicated double implementation of the same thing. And so you also have to know the basic things which are important here, and why you are implementing the pattern. You must implement it correctly. Patterns are not integrated like code building blocks. They are integrated by assigning roles to existing components, for instance. And you also should understand the patterns of the systems you are using. This was basically also part of my doctorate or my PhD thesis at Groningen. So how to understand systems using patterns.
But you're also with me regarding simplicity, because I think we have two possibilities, right? If your language and platform is expressive, I could say, I just write simple code, which is very clean and very readable. And if time comes and I will have to extend the code, the extension is very simple. Or I could say the extension is not possible or not for unknown reasons. So then I can start to abstract in order to encapsulate the unsecure or the fluid kernel, right?
So that's basically the keep it simple principle, and I think, or Ostrom, Occam's razor. So this is I think is very important. People tend to overcomplicate their software, and the best software which I ever saw, be Unix or Windows NT or whatever systems were out there, were the systems which were clearly built upon the principle of simplicity. Because this also allows users or developers to keep it simple. And I think simplicity is an art and maybe also a science, because it's not so easy to implement everything which looks simple after building the system. Had a lot of efforts in order to build it.
Yeah, building simple system is really hard because you have to. It starts with naming. It's really hard sometimes to find a proper name for something.
And if you look at Unix, you see pipes and filters. So
yeah.
This is where we got it from. And you see also these little mechanisms that let you build very complex workflows just by using these small patterns.
Okay, next episode, if I invite you back, we have to talk about architecture. It's even more interesting, and then LLMs. But
sure.
As a cliffhanger for our next meetings is about LLMs. So what I found out is, and this works perfectly, surprising. I found it. I mean, this is obvious, but for me, somehow I didn't thought about that. So the specifications, we talk about that. So the Java EE, EJBs, Jakarta EE, JAX-RS, and whatever, they were always open, and they are written in normative way. It means, shall, must, and so forth. The RFC, what was it, 2119 or something. There's an RFC which exactly describes what the shall, must not, and so forth are meaning. And these specs are HTML, crawlable, so they are publicly available, which means is LLMs know them just because they read the specs, because they are data hungry.
Sure.
Then I have a Jacobson, this UML. He invented this BC, boundary control entity, and very old structure or architectural pattern, which I thankfully used for 20 years at least. So all my projects are structured that way. And the LLMs also know that. So because they read all the papers and books and so forth.
Sure.
And now, if I use Java, I ground the LLM, so currently Claude Opus, to the API. I tell them very briefly, you are only allowed to write code against the APIs. And now magic happens because they know everything. My prompt can be extremely short, and they make almost no error. So far, no hallucination so far, because there's only one possibility. Because the specs were written in normative way, they see only one probability, and this works surprisingly well. So what I can do is create vehicles BC, create, machines BC, business component. This is my prompt, and they generate perfect code. And this is amazing. So this is what I do in project right now. And at the conferences I showed this, they said this is impossible. How what I did is a proprietary tool. It's like, no, it's just standard. Java was always open. So what I see right now is that Java has a huge opportunity because LLMs know Java that well.
Yeah, you're right. I think that's the basically reason why wipe coding works. So because if you are doing wipe coding, which I'm not a big fan of, then it only works if the system knows the specifications. Otherwise, it would fail. So if you get a program out of vibe coding, then there must be some prerequisites in order to succeed. And one of them is that the LLM already knows maybe Pygame or how to build an HTML, JavaScript, and whatever CSS style application. So there are the specifications, and it's using these specifications. Maybe not always correctly, but in the most times you get astonishing results.
Perfect. So thank you. It was a pleasure to talk with you. I think the first time we had a chat actually all these years on the podcast.
Yeah.
We know each other from emails and conferences, but I think we never did. We are both from Munich, more or less, and we had no chance, to have a chat.
Oh yeah, that's true. Unfortunately, but now it's
now it's done after 20 years. Now it's done.
Yeah.
Where people can find you on social media?
Basically, my LinkedIn account. Just search for Michael Stahl.
And Stahl is STAL, just Stahl, exactly.
And I have also a blog on Heise Developer.
Heise Developer blog, and you are the editor of Java Spectrum. Is a German magazine, a very popular one.
You will find my editorial and also very often articles which I wrote in the magazine.
And you have the coolest title ever. Principal Key Expert Engineer at Siemens Foundational Technologies. This is the best title so far, I have to tell.
Yeah, okay. I didn't think about that too much. Yeah, but you're right, I guess.
It sounds great, really. Yeah. Then thank you a lot, and I will re-invite you back. Well, maybe one episode about architecture, and then I would explain you what I'm doing with LLMs because the results are crazy good.
Thank you for having me, and it was a joy to talk to you.
Thank you a lot. See you next time.
See you next time. Bye.
Bye.